Hello, hi, good evening, good morning, good afternoon, everyone. Welcome to this masterclass session conducted by the Institute of Actuaries of India for ACET. Today we will be covering the statistics masterclass, and I hope you do have fun, you do understand it, and that you do go for ACET 2026. Starting with quick introduction, my name is Kevin Punya. I am a qualified actuary of the institute and a qualified chartered accountant. I have been working as an actuary for the last 5 years in consultancies, and my passion is teaching as well. So I've been teaching actuarial science over the last 5 years at a private coaching classes in Mumbai. Today the session is quite exciting. I will be covering the statistics that we have to do in ACET. So I hope everyone who is planning to do ACET or who has done ACET knows that ACET has 4 overall sections: your mathematics, statistics, data interpretation, and logical reasoning. And today we will cover the exciting one, statistics. It's very nice and personal to me because statistics is my favorite subject. And if you aspire to be an actuary, you will realize that statistics become like a part of your day-to-day life. So it's great if you have the good foundation of statistics, which is what ACET requires you to do. And if this is something that excites you, interests you, then just don't wait and go for it. Appear for the ACET, start with your actual exams, and I hope to see you someplace in the future in the actuarial net. Perfect. So yes, today, as I said, we will cover the statistics masterclass. The way I want to conduct this session, since this is a 2 hours masterclass, I don't want to go too deep into the syllabus. What I want to cover, however, is I want to cover the range of questions and the range of syllabus that ACET actually asks for. So what I plan to do is cover past exam questions from ACET. These are all multiple choice questions. And what I've done for your fun and to make it more interesting is I've divided these questions into 3 sections. That is simple questions, medium level difficulty, and actually difficult or perceived to be difficult questions. This way you can understand the good blend of questions that are asked in ACET, and along with that, this way you can understand the overall scope of the syllabus, how to best prepare for it, and how to actually go about appearing for ACET. So let's get into it. You will start with the simple questions, and we will have 4 questions in each categories. So we will have 4 simple questions followed by 4 medium level questions and 4 difficult level questions. I'll again repeat, these are all your past exam ACET questions. These are all taken from your past examinations, actual exam questions, so that you don't need to be worried about, oh, but this is what they don't ask in exam, or this is not how they ask. No, this is exactly how they ask in the exam, and this video will help you prepare for it. So we'll start with the simple questions, and this is our first question. So we have, you are estimating a population mean using the sample mean x bar, where x1 till xn, they all follow the normal distribution with mu and sigma square. What happens to the standard error if sample size is multiplied by 4? And you have 4 options. Okay. So if you're aware of normal distribution, this should be a relatively straightforward one. But in any case, I will explain you how to solve this and what is the answer. So you have x1, x2, these are all random variables till xn, and all of these follow the normal distribution with mu and sigma square. So mu, if you're not aware, mu is the mean of this distribution and sigma square is the variance. So mean and variance are obviously the two most important statistics or concepts in statistics. So whenever you look at a data, you want to look at the average, you want to look at the deviation, that is the variance of that particular data set. And that is exactly what we see over here. So, okay. All the xi's or all your random variables, they follow the normal distribution. And you are told that we are trying to guess the x bar. That is, we are trying to estimate this x bar. So if we are interested in finding, okay, what is the distribution of this x bar, what we can do is we can say that x bar is actually x1 plus x2 plus x3 and so on till xn upon n. So this is the definition of sample mean. That is, you just take a arithmetic average, simple average of the data points. So the summation of all your xi values upon n. And if I want to now find out the distribution of x bar, so because all these values follow the normal distribution, x bar, it's a good property, will also follow the normal distribution. So that's a very neat thing about the normal distribution. But then the question will come that what is the mean and what is the variance of this sample mean? So to calculate the mean and variance, we can actually make use of this equation above. So I can calculate the mean, that is the expected value of this x bar, by taking the mean of this equation. So all I'm trying to calculate is expected value of x1 plus x2 plus so on till xn by n. And this should be nothing but the expected value of x1 plus expected value of x2 and so on till expected value of xn, the whole upon n. Since n is a constant, its expected value is the value itself. Correct? And e of x1, e of x2, what is this? So as we already know, they all follow the normal distribution. This is simply mu, mu, and all of these are just mu. So you have n values which you are adding and all of those values are mu. So therefore, your numerator e of x bar, the numerator becomes n times mu upon n. Both gets cancelled off and you are just left with mu. So the expected value of your sample mean is mu. Perfect. No surprises there. If I have 10 values, each of them have a particular average, then the mean will also have the same average. That's what we are saying here. And now coming to variance. So variance of x bar will be variance of x1 plus x2 plus x3 and so on till xn, the whole upon n. And if you have worked with variance, you would know that a constant inside variance can come outside the variance, but you will see its square outside. So this is the n inside comes out as 1 upon n square. And what you have inside is variance of x1 plus x2 till xn. Okay, now how do I solve this variance component? So although the question hasn't specifically told us, we will assume, and we have to assume because there's no other way here, that all these random variables x1, x2, x3, these are all independent variables. So that is, they do not depend on each other. And it's an important assumption when it comes to calculating combined variances like this, because if they are not independent, then you will have to calculate the covariance aspect as well. But over here, we will just assume they are independent. And accordingly, what we get here is then 1 upon n square into variance of x1 plus variance of x2 plus variance of xn. And this kind of gives away our answer, because now we have variance of x1, x2 and so on, which of course is nothing but sigma square, sigma square, sigma square. So you are adding sigma square, that term, n times. So your numerator is now n times sigma square upon final denominator is n square. It gets cancelled off and your variance of the x bar is sigma square by n. And this is important. If you already knew sample means, you would know this formula by heart, that actually x bar follows the normal distribution with mu comma sigma square by n. And if you did not, then it's quite intuitive. If I have 10 values, each of them have a particular variance. Now, if I start taking the average of those 10 values, that is, if I take the mean of those 10 values, the variance will be low compared to the individual variance because the sample is getting big. And that's exactly what we see when we do sigma square upon n. So x bar follows normal with mu sigma square upon n. Anyone who has studied stats will probably know this answer by default, that x bar follows normal with mu comma sigma square by n. And why is this important? Because we are being asked in the question that what happens to the standard error if sample size is multiplied by 4. That is, standard error is nothing but the standard deviation. That is the standard deviation, which is nothing but the square root of your variance. So the definition of standard deviation is that it is the square root of your variance, which is nothing but then sigma upon under root n. So your standard error is sigma upon under root n. Now we are being asked what happens to the standard error if the sample size is multiplied by 4. That is, if this was the original standard error, and now if I have, I'll just write here in the small box, if I have sigma upon the sample size is multiplied by 4. So instead of n, now the sample size is 4n. Okay, so the new sample size is 4n. So sigma upon under root 4n, and that is naturally sigma upon 2 under root n. So as you can see, your original standard error sigma upon under root n, that is multiplied by 1 by 2. So 1 by 2 into sigma of under root n, which means your standard error has actually halved. So your correct answer is B over here. That is, your standard error is halved. That is, you divide it by 2 when you multiply the sample size by 4. So your answer here will be B. I've put this question purposely in the simple categories because people who are appearing for ACET typically are aware of the normal distribution. In case you aren't, then maybe you'll have to understand these steps first before understanding the result. But otherwise, this result is quite intuitive because your standard deviation is proportional to square root of n. And that's exactly what you see, that when you increase the sample size by 4, the square root of 4 is 2, and you are inversely proportional, so your standard error is actually halved. So hopefully you guys understood this and appreciated this sum. With that, we are done with the first so-called simple sum of the day, and we can now move forward to the next one. So it's a very typical ACET question, that is, the average marks of all boys in a class is 52, while the average marks of all girls in that class is 60. Then the average marks of all students in that class will be, and you are given 4 options: 56, indeterminate, but it will be between 54 and 58, indeterminate, but it will be between 52 and 60, or none of the above. So how do you go about this sum? So you are given that there are, let's say, X number of boys. This could be 10, 15, 20, 50, I don't know. Let's call it X number of boys. And Y is the number of girls. Okay. Now, you are being told that average marks of boys is 52, which means total marks of boys upon number of boys, that is X, is 52. Correct? Because total upon number of boys will be the average. So therefore you can say that total marks by boys is 52x. And finally you will have total marks of girls 60y, and that means therefore total marks of the class, that is of boys plus girls together, of class is 52x plus 60y. So 52x plus 60y is the total marks achieved by the students in this particular class. The problem is we don't know what is x or what is y, and we don't have enough information for us to be able to calculate the value of x and y. Which means one thing is certain at this point, that is the answer will be indeterminate. That is, we have no way to actually find out what is the correct answer, right? Because for getting the correct answer, I need the value of x, I need the value of y. However, we don't have any condition or any additional information which tells us how many boys and how many girls. It could literally be same number of boys, same number of girls, or it could be that, boys are just 10, girls are 90, or vice versa. So we don't know that, which means our answer will be indeterminate. Now, if there was only one option saying indeterminate answer, I would ideally stop here. But here you see there are two ranges. One says indeterminate, but between 54 and 58. And the other is indeterminate, but between 52 and 60. So how to mathematically solve this? How to mathematically be sure that, the answer minimum will be 52 and maximum will be 60? So how do you get the minimum average in this case? So if you understand correctly, for the minimum average, I have boys, I have girls. Boys have scored significantly less than girls, 52 and 60. If you understand correctly, to get the minimum average, that is, what is the minimum that the average could be, I should have maximum number of boys and minimum number of girls in my class. Correct? Because more boys, which will mean that low average, and vice versa. So what is the boundary condition? Simply, for minimum average, we will assume y is 0. That is, there are no girls in the class. It's a hypothetical situation, but we'll assume that there are no girls in the class. So then what is the total class average? Let's calculate this. And this will simply be 52x plus 60y upon x plus y. That's the total class average. Now y is 0, so this simply becomes 52x upon x. This becomes 0, this becomes 0, which is 52. So the minimum average of the class is certainly 52. And we'll do the reverse for calculating the maximum average. We have the answer already. The answer is C, but we'll just for double confirm, because there is an option of none of the above. For maximum average, you will simply say that let's now make x as 0. That is, there are no boys in the class. And you can clearly see that the total class average in that case is 52x plus 60y by x plus y. Both x values will go away because they are 0, and this reduces to 60y upon y, that is 60. This should be quite intuitive, because if boys average is 52 and girls average is 60, the total average has to be a value in between that, correct? Because as we apply the boundary conditions, we cannot go below 52 in any case, right? If the lowest average is 52 of the two groups, then how can the total average be lower than that? There's no possible. It's not possible, right? So the final average will always be a number in between that. In fact, you don't need to do all these calculations. If you're aware of the concept, you can just read the question and confidently mark that yes, option C is the correct one. That is, the answer will be between 52 and 60. What I did is I showed the mathematical proof and concept that why that is the case. So as you can see here, the answer will certainly be option C. That is, it is an indeterminate answer, but it will surely be between 52 and 60. So hopefully this was a question which was an elementary one. You did not require knowledge of distributions. All you needed was your common statistical knowledge. And with that, we can see that the answer is C. If there are no issues here, we then move to the third question, which is this one. A very nice probability function one. It says a commuter must pass through 5 traffic lights on her way to work and will have to stop at each one that is red. Okay, of course. Suppose the probability distribution for the number of red lights she hits is given below. She hits does not mean that she is hitting those red lights. It simply means that she will observe a red light and she has to stop. Just for clarification. But yes, this is the distribution that is given, that you have x 0, 1, 2, 3, 4, 5. So you could have 0 red signals while traveling to home, or you could have maximum 5 signals. That's what we are showing. And she's also calculated the probability of each of those. Apparently she has a lot of free time. So 0 has 0.05 probability, 1 has 0.25, and so on. Whenever you are given a probability type question, the first thing you should always check, you could do it as a mental note or just check it directly, that sum of the probability should always be equal to 1. And that's just the universal truth about probabilities. If that is not the case, and there is something in the question which is missing, or you just have to reread the question. But in this case, let's try and find out. In this case, it should ideally be 1. So 0.05 plus 0.25, that's 0.3, plus 0.3, that's 0.6, plus 0.2, that is 0.8. Adding this is 0.95, and then you have 0.05. So this adds up to 1, and then we are happy with the probability given. You are being asked to calculate the expected number of red lights she hits each day. So let's get into it. You have to calculate the expected value of x, and you can just directly apply the formula which you might have heard. Is expected value of x. X is a random variable whose probability is given. The expected value is simply summation of the x values multiplied by probability of x taking those values. For the entire range of x, we have to add the x values multiplied by their probability weights. So kind of getting a weighted average with the weights being probabilities. So we just apply this formula, that is E of x is 0 into 0.05 plus 1 into 0.25 plus 2 into 0.3 plus 3 into 0.2 plus 4 into 0.15 and plus 5 into 0.05. Now you can use your calculator at this point. You don't need to multiply this first one, it's going to be 0. After this, you have 0.25 plus 0.6, that's 0.85. This will then lead to 1.45 plus 0.6, that's 2.05, and plus 0.25. So this should be equal to 2.3. You can double check this using your calculator. But the expected value of x, which is nothing but summation of x into its probability, is 2.3. And do we have that option? Yes, the option A is 2.3. So your answer here, very straightforward, is 2.3. Hopefully this was clear for everyone, and this is again a very commonly asked question in your ACET, that is just you're given a probability function, a probability distribution, and you have to try and find the expected value, sometimes the variance, those types of things. Okay, so she can expect that there will be an average of 2.3 red lights which she will see. And that's the thing about averages, that is obviously on a given day you will not see 2.3 red lights, right? You will either see 2 or 3. There is no 0.3. But that's what about averages. Averages give you an idea that you are expected to see 2.3 lights, which means it's close to 2 that that's what you'll see. But out of every 10 days you travel, there will be 7 days you will have, let's say around roughly 7 days you will have 2 red signals. There will be 3 days roughly where you will have 3 red signals. So that's the kind of intuition which you have to develop along with the averages. Perfect. So that was your question 3. And with this, we are now down to the last question of the simple category, which is this one. The thickness X of steel sheets produced by a rolling machine is a uniform random variable. So uniform is again a type of distribution. It's the uniform distribution. with the values between 150 and 200 millimeters. Any sheet that is less than 160 millimeters thick must be scrapped. The probability that sheets produced by this machine are to be scrapped is. Okay. So what are we told? We are told that X, which is the thickness of the sheet, follows the uniform distribution. And in uniform distribution, there are usually two parameters, which is your lower limit and upper limit. Correct? Uniform distribution is a very good distribution. You are just given the limits, and the probability that any of the values between them is achieved is exactly the same. So that's the uniform distribution. Here you have uniform between 150 and 200. Now you are being asked that, or you are being told that any sheet that is less than 160 must be scrapped. So you kind of have, let's say, this distribution 150 to 200. Because it is a uniform distribution, your probability will be exactly the same from 150 to 200. And obviously when you add these probabilities, it should be 1. They haven't told us directly, but we will assume this is a continuous uniform distribution. So there are two types of uniform distribution. It could be a discrete one or a continuous one. Although here it does not really matter, but I'll still go ahead with the continuous version of the uniform distribution. That is, the thickness of sheets can take any value, right, in decimals, etc. So we will go ahead with the continuous definition. So with that, now what we need to actually find is the probability that X is less than 160. So how do you find probability that X is less than 160? So for this, we need to know the CDF, or the cumulative density function of the uniform distribution. So if you have uniform distribution with parameters A and B, then how do you get the CDF, or how do you calculate probabilities, less than probabilities, cumulative probabilities of the uniform? And I'll let you know the formula. The formula is simply probability that X, your random variable, is less than any particular value. Let's say it is less than Z. So probability X is less than Z is actually given by Z minus A upon B minus A. So the formula is simply Z minus A upon B minus A. And the intuition is quite straightforward. That is, in this 150 to 200, I am trying to find probability that my X, or my random variable, is less than 160. So kind of like this is the region I'm trying to find. And the intuition is that if I just look at this particular one, the total range is of 50. So from 150 to 200, you have a range of 50. And what we want to cover is a range of 10. So what we're trying to say is the total range is 50. We only want to cover the 10 millimeter range because that's the one we are going to scrap. And logically, then what is the probability of us finding that? That will simply be 10 upon 50. And that is exactly what this formula does. So Z minus the lower limit upon B minus the lower limit, or upper minus lower limit. This denominator is nothing but the range, which is 200 minus 150 for us. And this numerator is our required or desired region, which is 160 minus 150. So that's 10 by 50, which is nothing but 20%, or 0.2 as the final probability. So do we have that option? Yes, you can see option C is exactly 0.2, and according to your answer here will simply be option C. Yes, so that is the end of your simple category of questions. Before we now go to the next section, medium, I just quickly want to highlight the importance of ACET, that is the Actuarial Common Entrance test for you guys. because you guys are thinking about actuarial science as a career option at this point, I would suggest ACET is a great starting point for that. The reason is, what are you going to learn as an actuary? What are you going to apply your whole life as an actuary? That is maths, stats, logic, understanding data, understanding different problems and knowing how to solve them. And these are very nicely and neatly packed in the ACET for you guys. And it's not like you have to study a whole bunch of new things for it. Most of it is what you've probably studied in 11th and 12th, and with a little bit of extra sort of practice on the logical reasoning side and everything. But this is a great way for you to understand that the types of questions that you see in ACET and the type of application of mind that you have to do for ACET kind of mimics what you will be doing in your future papers and in your future life as well. So that is why it's a great first step in becoming an actuary. The timeline is quite straightforward after your 12th exams, which is when you typically give all these other entrance tests as well. You can give ACET and sort of prepare yourself for what's going to come. Right? The attempt for which we are discussing is the 2026 one. Registration will close on 26th December and your exams are on 10th of January. You can scan this QR code and register now, or you can go to II's website and register for ACET. And just speaking about why ACET, or in general why actuarial science. Actuarial science, I'm not sure how well researched you are, but it is easily one of the most in-demand skill and a growing skill and profession in India. You have wide range of opportunities that is in India, outside India. The reason is the kind of things you learn in actuarial science have wide application, right? It's not specific to a region, it's not specific to a country. These have wide applications, because of which there is global demand. It is an area which is still not very well tapped by the Indian students. So if I just give you a number, the number of chartered accountants in India are 3.2 lakhs, which is a small number if you compare to the size of India. And now if I tell you the number of qualified actuaries in India, then that number, as per my best knowledge, the number of students who are qualified with the IAI are around 550 to 600. That's it. It's in triple digits, not even 4 digits yet. And the opportunities, the roles, they are increasing, the fields are increasing, and that is why you see these are high paying roles. You have huge demand, and you have a very sort of good analytical career as well, because you do get to make those mathematical problem solving decisions on a daily basis, which is quite rewarding. So that's the reason why you should just go ahead with registering for ACET and starting your actuarial journey. So without further ado, now we can move on to the next section, which is the medium level difficulty section for your statistical questions. Before I move on to solving this, a quick point. So the passing mark for ACET is 50%. All exams and all sections have some difficult questions, some easy questions, some medium questions. In my experience, what I've seen is simple questions are those which a lot of people can answer, whether you have prepared well or not. Difficult questions are those which very few people can actually answer in the exam time. I'm not saying because of lack of capability, but because the exam is a time domain exam. You have to think on your feet in the exam, and that is quite challenging for somebody as a student. So difficult questions are some of those questions which even very well prepared students may fail to answer. The real difference between those who clear the exam and those who do not, in my experience, has always been these medium types of questions. Because as I said, the exam will be a blend of all three categories. If you are well prepared, then you should be able to answer these medium level difficulty questions just like you do for the simple ones, right? And that is exactly what will push your score from, let's say, 30-40% to 60-70%. which is from a fail to a pass. So that's why it's important to prepare, and it is important to make sure that in the exam you will see difficult questions, but you don't need to be disheartened by them. There is a chance you may go wrong on those questions, but as long as you cover your basics, that is a simple and the medium questions well enough, you should be able to pass the exam. So don't get disheartened. Apply proper timely strategies. Ensure you cover all the questions in the exam. Do not miss on any of the question, and you should be good to go. Okay. So on that note, we now move to the first medium level question, which is this one. So we are told two regular unbiased six-faced dice, that is a normal dice which we play for Ludo, etc., with faces number 1 to 6 are rolled, and the higher of the two numbers is recorded. Okay. Let this be a random variable n. Then you are asked the median of n is. It's a very interesting question, and I would say even more than that, with very interesting options. And the reason is because if anyone has solved a dice related question, then you would remember that the mean of a single dice, the mean of the top number of a single dice is actually 3.5. So anyone who reads like, okay, this is a dice related question, you are being asked something, and if you are short of time, you don't have time to solve, the intuition will go with directly 3.5, which is obviously the wrong answer in this case. But that's what ACET sometimes does, is they will give you purposely an option which kind of feels relatable to you, and you may just mark it in the interest of time or something like that, and that would be wrong here. We are being asked first not the mean but the median. And also, very importantly, we are given this condition that what we are actually finding the median of is a random variable which is higher of two values that you see on a six-faced dice. Okay, so how do we do something like this? N is defined as, I would say, the maximum of x1, x2. What is x1 and x2? x1, x2, these are both simply the random variable which is top number of a dice. So whatever number you get on top, let's say I get numbers 2 and 4. x1 is 2, x2 is 4. Then n is the maximum of these two, which is n will be 4 in that case. I get 6 and 3, then n will be 6. If I get 5 and 5, then n is 5 because maximum of these two is 5 only. So x1, x2 are simply your normal dice, and n is the maximum of x1, x2. If you guys have understood dice, and if you guys have understood or studied a sum on dice, you would know that this means that x1 and x2, they follow the uniform distribution. That is the discrete uniform distribution with the lower limit as 1 and upper limit as 6. So 1, 6. Because all the values 1, 2, 3, 4, 5, 6 have the same probability of occurrence 1 by 6, and that is why x1 and x2 both follow the uniform distribution with 1, 6. Correct? Before we move ahead, a quick revision. Median is simply the middlemost value of a distribution. It's quite common that, even at advanced stages, people confuse between mean, median, and mode. I hope you guys are not confused. In any case, I'll just clear this. Median is the middlemost value of a distribution. That means mathematically what we are saying is half of the distribution lies below this value and the other half lies above this value. So if I just have any distribution, let's say this is a particular distribution. If I'm saying that my median lies here, median is 5, for example, then what I'm saying is the lower half probability area under this shaded region is 0.5 and the upper half probability is also 0.5. So that's the definition of a median. Just for completeness, mean is the arithmetical average, which is when you add all the random variables and divide by n, or if it's probability weighted, then the sum we had done earlier, which is multiply the random variable with its probability and get the sum total. So that's the arithmetical average. And mode is the most frequent variable. So which variable do you observe the most number of times in a distribution? That's mode. So for example, in my above distribution, I can show you the mode using a separate color, that is the peak value of this distribution. And you can see the peak is somewhere around here. So this, whatever the value is, let's say m is 4 over here, example, this is the mode. M is 5 is obviously the median, and mean you can just calculate as using any of the formulas, correct? So in our case, we want to find the median of the particular distribution. The mathematical way is to say that probability x less than equal to m, capital M, is 0.5. Then we would say m is the median, correct? Which is half of the distribution is below this, half is above this. So in our example, now how do we find that? We want to find the median of n. N is nothing but maximum of x1 and x2. So I want to find out median of n, that is n being less than equal to some value m should be 0.5. I can simplify this to say that therefore probability that maximum of x1 comma x2 is less than equal to m is 0.5. So the definition of n is it's a maximum of x1 x2, and that's what I substitute here, that maximum of x1 x2 should be less than equal to m. Now if I'm saying that maximum of two numbers should be less than m, correct, can I say that it means both the numbers should be less than m? Why? Let's say there are two numbers, 2 and 4. If I'm saying that the maximum of these two numbers should be less than m, so can I say all I'm saying is 2 should be less than m and 4 should also be less than m. Only then the maximum of these two numbers, which is 4, will be less than m. So that is a very neat way to split out the maximum. That is, now we can say therefore what we want is both x1 and x2 should be less than m. So x1 comma x2 both should be less than equal to m. And this is a joint CDF kind of thing, that we want two variables to be less than a particular value. Obviously x1 and x2 are independent of each other, so this probability is nothing but the probability that x1 is less than equal to m multiplied by the probability that x2 is less than equal to m. And this is a real key core concept behind this, that if I want the maximum number to be less than a value, that means I want both the random variables to be less than that value. And obviously I want this to be equal to half. So now what we can do is, there are multiple ways in which we can proceed, and one straightforward way to do this is, just write down all the possible values of m here, which is 1, 2, 3, 4, 5, 6, and then let's write down the probability that x1 could be less than equal to m and probability x2 could be less than equal to m. These will obviously be the same. We want finally the product, that is the final probability that n is less than equal to m, which is nothing but the product of these two. So the way we can do this is, when it's 1, probability that x1 is less than equal to 1 is simply 1 by 6. This is also 1 by 6 and this is 1 by 36. For 2, this is simply 2 by 6, 2 by 6, and this is obviously 4 by 36. You just need to multiply this. For 3, the probability that x is less than 3 or equal to 3 is obviously 3 by 6, 3 by 6, and this is 9 by 36. 4 is 4 by 6, 4 by 6, and this is 16 by 36. Finally, for 5, this is 5 by 6, 5 by 6, and this is 25 by 36. And for 6, this is obviously 1, 1, and this is 1. You want to find out that which of these satisfies the 0.5 equation. So if you calculate this in fractions, this is obviously not half, this is not half, this is not half. This is slightly less than half because 18 by 36 is 0.5. So this is slightly less, I would say this is less than 0.5. And 25 by 36 is obviously greater than 0.5. So where do we satisfy this condition? We satisfy the condition that x less than equal to m is 0.5 at the 5th row. That is this one. Which means that your median is simply phi. So the median is phi, that is the maximum of two values. Your middlemost observation in that case will be phi, and that is your final answer. So I hope you appreciate this is how you have to combine the logic of uniform distribution along with the maximum knowledge and get to your final answer, which is like this. There are other ways in which you could have solved this, but I just showed you the most intuitive way which you may want to use in exam. And with that, you see that the answer is C, which is the median is phi. Okay. So hopefully this was clear. A very good question, a very nice ACET style question. If you are clear with this, let's move to the next one, which is question 2. And you can see again we have a height related or a classroom related question. So the average height of all students in a class is 170 centimeters. If 5 new students are added, the average increases to 172. If all these 5 new students have the same height, the number of students originally, that is before the addition of 5 new students in the class, is what? 20, 25, 30, or insufficient information. So let's see. You are being told that the average height of students is 170. You are not given the number of students in the class. So in a way, what you are given is that total height upon, let's say the number of students before those new 5 students was x. So total height upon x is 170, and therefore total height of the class is 170x. Okay. Now you're adding 5 new students to this class and the average increases to 172, which means the total height, the original total height plus those 5 new students, so 5 times y. What is y? Y is the height of the new students, height of new students. Because we are told that they are the same, we can just say 5 times y upon x plus 5, because now you have more 5 students. So this is 172, which means therefore total height is 170x. So you can say 170x plus 5y is 172 times x plus 5. And you can simplify this. This simply becomes that 170x plus 5y is 172x plus 5 times 172, and that is simply 860. So 860. You can just take all the variables on one side and therefore you get something like 5y minus 2x is 860. That is it. You only have this one equation. You do not have a corresponding simultaneous equation for the other variable. If you are aware with mathematics, or if you're not, then this is a very nice golden rule which you should remember, that if we have n unknown variables, if there are n unknown variables, we need to have at least n equations to solve them. So if I want to find the value of y and x over here, I need to have at least one more equation Because these are two unknown variables, I should have at least two equations to be able to solve the values for x and y. Here, this is the only equation I have. There is no separate information given apart from this. For example, if I just take any value of x, let's say from the options, let's say if they are saying x is 20. So I can take x as 20, which will simply mean that y is, you can just calculate this, 860 plus 40, 900, 900 upon 5. So y will simply become 900 by 5 or 180. If I take x as 25, then can I calculate y? The answer is yes. If x is 25, then this becomes 910, and 910 divided by 5, you will get a corresponding value of y as 910 upon 5, which is 182. Similarly, x as 30 will also give you another value of y, which is simply 920 upon this, so 184. So the idea is, because you only have one variable, what you have here are infinite solutions. And because you have infinite solutions, you cannot pin down to a single solution, which is why in this question, your answer will simply be D, that is, you have insufficient information. So the answer is D. And as a student, I know sometimes how difficult it is that in an MCQ, you mark this type of an option that is, the answer cannot be determined or insufficient information. As a student, you always think that, oh, this option is given just to, fill those 4 options. The real answer is between those A, B, and C. And in this case, that is not the case. Here you can see that we only have one equation, we only have one way to figure out 2 variables, and that is simply not enough. So hopefully this was a good twist kind of a question number 2. If everyone is clear with this, they can now move to the third question of the medium category, which is this one. So here we are told, let x be a continuous random variable with the probability density function as 1 upon b minus a and 0 otherwise. Okay. So before moving ahead, you can very clearly see that this is a uniform distribution question. That is, f of x, what they have defined is the PDF of a continuous uniform distribution. Okay. So keeping that in mind, we can now move on to solve the question more comfortably. That is, the mean and the 25th percentile of the distribution are 8 and 6. Then the 90th percentile of the distribution is what? So I'll try to solve this using 2 approaches. Approach 1 is when you figured out that this x is nothing but a uniform distribution, that is a continuous uniform distribution over the range a comma b, correct? So we know x follows uniform distribution. With that in mind, can we move ahead and solve this? The answer is yes, because if x follows the uniform, we know that expected value of x or its mean is a plus b by 2. A plus b by 2, this is the mean or average of a uniform distribution, which we are told in our case is 8. So therefore I can simplify this, that is a plus b is 16, kind of my equation 1. And then we are told that the 25th percentile of the distribution is 6. So what is the 25th percentile? A quick revision. Probability that x is less than equal to, let's say, x1. If this is 0.25, that is the CDF value is 25%. 25% of the distribution lies below this value. Then x1 is nothing but the 25th percentile value. So that is what we understand when we say 25th percentile. Similarly, 90th percentile is a 90% of the distribution falls below this, correct? Those who give entrance exams, they know this percentiles in and out, 99 percentile and whatnot. And this is exactly the concept. Okay. So probability x less than equal to x1. that is the CDF. Now, do we know the CDF of the uniform distribution? The answer is yes. Probability X is less than or equal to X is simply X minus A upon B minus A. So, in the current case, we are given that probability X less than or equal to 6 is 0.25, which means therefore 6 minus A upon B minus A is 0.25. And now we can simplify this, that therefore 6 minus A is 1 by 4 B minus A. We can get this 4 here, that is therefore 24 minus 4A is B minus A, and therefore you can just take the 4A on the other side, that is this becomes 3A plus B is 24 is remaining on the other side, and this is obviously your equation 2. So now I have two variables and I have two equations. This is something I can solve now. Okay, so A plus B is 16, 3A plus B is 24. What you can do is simply do 2 minus 1 and you will get 2A is equal to 24 minus 16, that is 8. So therefore A is equals to 4. And because A is equals to 4, this gives us B, that is A plus B is 16. So this gives us B as 12. So we get that our X follows the uniform distribution with 4, 12. And with this knowledge, now we want to find out the 90th percentile. Can we do this? Absolutely yes. So probability X less than or equal to X90, I'll just write it X90, which is the 90th percentile, as 0.9. So therefore X90 minus 4 upon 12 minus 4 is 0.9. And now you can solve for X90, that is X90 is 8 into 0.9 plus 4. So that is 7.2 plus 4, which is 11.2. So 11.2 is the answer, and you can see option B gives us that. So the answer to this particular one is simply option B. Correct? So hopefully this was clear. And as I said, if you understand that this is a uniform distribution, doing this is just the matter of mathematics then. What about the second approach? The second approach is, what if you do not realize that this is a uniform distribution? And it can happen, right? In exam pressure, you read the question, but you're not very clear whether this is uniform. Or if you don't recall the expected values or the PDF value formulas, right? The CDF formulas, you don't remember them. Then how do you go about doing this? So then what you can do is you can use first principles to calculate this. So what do I mean by that? So expected value of X can be written as the integration over the entire range A to B of X f of X dx. Correct? So you can just calculate the expected value using the first principle. For a continuous variable, this will be integration over the entire range of distribution into X f of X dx, and that is obviously integration A to B of X upon B minus A dx. You can solve for this. This becomes X square by 2 over the range A to B into 1 upon B minus A. This is constant. I've removed it outside. And the idea is, when you simplify this, you should get B square minus A square on the top upon 2B minus A. And B square minus A square can be written as B minus A, B plus A, or A plus B upon 2B minus A. And that is simply A plus B by 2. So you can see expected value of X is A plus B by 2. This was obviously the same thing which our formula directly had, that expected value is A plus B by 2. But if you do not recall this, you can calculate and get the answer like this as well. And the idea is not to make your life difficult. It's like if you do not recall, then what will you do? So then the point is you can still proceed with the answer. You don't need to stress upon this. Proceed with the answer. Use your first principles. You will get the same solution. Similarly, you can get the CDF as well. I will not calculate the entire thing here, but the CDF, f of x, this also you can easily get. So this will be over the range a to the value x of your f of x dx, because we have x here, so we can just say f of s ds. But that's exactly what the CDF is, and when you simplify this, you will get the same formula, which is x minus a upon b minus a. The point is, once you get those, the next part of the sum is exactly the same. You have two equations and two variables, you solve for them, you get this final answer. But if you don't understand, or if you don't realize that the x follows uniform, you can take the first principles route and still get to that answer. It will be longer, but it will still be correct. Okay. So that was your question 3 of the uniform distribution one of the medium level questions. And now we move to the fourth and final question of the medium level questions, which is this one. So very interesting one. It says, in a city's central station, trains arrive from two independent railway lines. Quite normal, quite common. Line 1 follows a Poisson distribution or a Poisson process with a rate of 4 trains per hour. So again, you need to know the distributions here. So you have Poisson with a rate of 4 trains per hour, and line 2 follows a Poisson process with a rate of 6 trains per hour. All arrivals are independent. Then what is the probability that exactly 7 trains arrive in that 1 hour period? And you are given 4 options. Okay. So we are given that x1 is, let's say, number of trains from line 1, and similarly, let's say x2 is number of trains from line 2. We are given that x1 follows the Poisson distribution with 4 as the parameter. Correct? Why 4? Because line 4 follows a Poisson with a rate of 4 trains per hour. Line 2 follows with a rate of 6. So x1 follows Poisson with 4, and x2 obviously follows Poisson with 6. Okay. All arrivals are independent, so there is no dependency of like, okay, line 1 train will come only, then line 2 will come or something like that. They come at their own schedules, at their own platforms. You are being asked, the question is very important, what is probability that exactly 7 trains arrive at the station in a 1 hour period? Now, total number of trains that arrive in the 1 hour period, that is what they are asking. And that, if you understand, is nothing but total trains in 1 hour will actually be x1 plus x2. That is trains from line 1 plus trains from line 2. Okay, so total trains is x1 plus x2. We have a distribution for x1. We have a distribution for x2. How will we find the distribution for total trains? So if you are aware with Poisson distribution or the Poisson process, you will know that if x1 and x2 follows Poisson, that is, let's say x1 follows Poisson with lambda 1 and x2 follows Poisson with lambda 2 as the parameter. As long as x1 and x2 are independent, you have what we call as the additive property of Poisson distribution. That is, therefore, x1 plus x2 in this case will follow also the Poisson distribution, and the rate will be lambda 1 plus lambda 2. This comes from the additive property of Poisson. Chances are you might have heard of this or you might not have heard of this. My suggestion is more from an exam level sort of sharpness point of view. Even if you're not aware, okay, no such property exists. Still, what is your best way to solve this sum? your best way is to actually assume that the total also follows Poisson with 6 plus 4. Because on an average, how many trains are coming over there? 10. What is this 10? 4 plus 6. So the distribution has an average of 10. Poisson distribution's parameter is accordingly 10. So this is an intuition which you can apply in case you are not, clearly aware of this additive property. But here we are that, okay, x1 plus x2 is Poisson with lambda 1 plus lambda 2, which means in our case, x1 plus x2 follows Poisson with 10 as the parameter. And now all we need to find is probability that x1 plus x2 is 7, because that's what they have asked. What is probability that exactly 7 trains arrive? And if you are aware of the probability function of Poisson, it is something like this. That is e raised to minus lambda, lambda raised to x upon x factorial. So this is the PDF for probability distribution function of Poisson distribution. So in our case, this will be probability x1 plus x2 is equals to 7. The lambda is of course 10. So you will have e raised to minus 10 into 10 raised to x. X is 7 upon 7 factorial. So let's see if we have an answer that looks like this. And as you can see, it's the first one, 10 raised to 7, e raised to minus 10 upon 7 factorial, which is what the answer is. And accordingly, we have the answer A. So with that, we are happily done with the medium level difficulties section of today's masterclass. And if all great, then we can now move finally to the so-called difficult level section. So we finally move to the difficult questions and let's get into it. So your first question is this. A random variable n is drawn from the set 0, 1, 2, 3 till 9 such that probability of j being chosen is directly proportional to j cube. Okay. Let small m and capital M be the median and mode respectively of n. Then what is the magnitude of capital M minus small m? Very interesting question. And let's see how to proceed. So the problem with a difficult question is, you're just too overwhelmed. You don't know how to proceed. So first thing is, what are they saying? What is a probability function? So it's like, it's directly proportional to j cube, which means 0 is proportional to 0 cube, 1 is proportional to 1 cube, 2 cube, 9 is proportional to 9 cube and so on. So your probability of x being j is proportional to j cube. So can we say that this means therefore probability x will take the value j is a constant multiplied by j cube. Simple. So k times j cube. Perfect. Now, can we actually find this k? The answer is yes, we can find this k because summation of the probabilities x being j for the entire range of this x, right? That should be 1, which means therefore summation of k times j cube should be 1. Now k is a constant, so therefore k into summation of j cube is 1. What is j? J goes from 0 to 9. This is the range, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So kind of what you need to do now is therefore k into 0 cube plus 1 cube plus 2 cube till 9 cube, that is 1. If you calculate this, you should get this is 2025 times k is 1 and therefore k is 2025. So, or rather 1 upon 2025. So that is the value of k. K is 1 upon 2025. And therefore we get that the probability that x takes the value small j is actually j cube upon 2025. So we have solved for the probability function. And this is how you need to think, right? It's proportional. Proportional means it is certainly multiplying with a constant. Now, how do I find the value of this constant? So I apply the basic principle of probability that sum of all should be 1. And then I get that, okay, probability x is j cube upon 2025. Great, we get this. Now, what is the question asking us to do? It is asking us to find the difference between the mode and the median. So first of all, what is median? What is mode? If you apply the formula and do it, you will be able to find the answer, but it will be unnecessarily complicated. That's why I say having your foundations or having your basic principles accurate is very, very important. For example, let's just try and plot what this probability function will look like. Okay, so I have something like this. I have the values 0, 1, 2, 3 till let's say 8, 9. This is what I have in my x-axis. These are the random variable values. And if I try to plot their probabilities now, that is j cube upon 2025. Can I say I'll get something like this, that the first probability of 0 is simply 0. Probability of 1 will be 1 upon 2025, which will be very small. Then 8 upon 2025. So this will be kind of like 1 by 2025. This probability of 2 will be kind of like 8 upon 2025. 3 will be 3 cube upon 2025. So kind of like 27 upon 2025. And so on, correct? So these probabilities will simply be an increasing function, correct? So kind of like just very nicely, not a linear. I've just shown you as a linear so that it's very nicely appearing, but it's a sharply increasing function. If I in fact try to correct this shape, it should look something like this. So it's a sharply increasing function, kind of like this, and it will go very up for 9. And now if you remember, what is mode? Mode is the most frequent observation. If you understand 0, 1, 2, 3 with the probabilities being proportional to j cube, probability j cube by 2025 continuously increasing, the most frequent observation, that is the observation for which probability is the highest, is definitely in this case 9. Why? Because probability will simply be highest over here, highest for 9. So you don't need to apply any formulas, any summation or integration. Just by core conceptual knowledge, you can realize that, okay, here the mode is simply 9. So we have found out capital M is 9. Okay. So that's great. Now we want to find out the median, because the other thing that we need to find is a small m, which is the median. Again, you can be the absolute kind of student wherein you just plot that entire frequency table with the probabilities and the CDF and see where that 0.5 cutoff happens, which is what we did in the earlier sums as well. You can do that, or you can think about it logically that, okay, maximum probabilities are around is 9, the second maximum is 8, and so on. So the probability that, or the chance that 1 will be the median is absolutely negligible, 2 will be the median is negligible, 3 will be the median is negligible. The median has to be a higher number, because the probability is sharply increasing. The median ideally has to be a higher number, correct? So how do I find what is the median? So let's see, can 9 be the median? The answer is no, because probability x less than equals to 9 is simply 1, correct? So 9 could be the median if probability that x less than equal to 8 is less than half, correct? If it is less than 0.5, then 9 is the median. So let's try to find that. Okay, what is probability that x is less than equal to 8? If this is less than 0.5, let's say this probability is 0.4 or something, then 9 is the median. What about probability x less than equals to 8? So if I try to calculate this, can I say this is nothing but 1 minus probability that x is equals to 9, correct? Because simply 1 minus probability that x takes value 9 is less than equal to 8. And that is 1 minus 9 cube upon 2025, which is 1 minus this 9 cube is 81 into 9, that is 729 upon 2025. And if you solve this, you should get an answer that is 1 minus 729 upon 2025. So I'll just use this handy calculator, and the answer is 0.64, which means x less than equals to 8 is 0.64. So 9 is certainly not the median. Now, if 8 is the median, when will 8 be the median? When x less than equals to 7 is less than half. Correct? So that same logic you have to apply. See, you were always doing this only. You were just applying this from the smallest to the highest number, because that's the intuitive way to finding CDF. Here, because we know the median will be a higher valued number, I have started from the opposite end. That's the only difference. Correct? So the next thing, probability x less than equals to 7, and this is 1 minus probability x equals 9 minus probability x equals 8. So I'm subtracting the two possibilities which are there for less than equal to 7, which is 9 and 8. 9 we just found out that 729 upon 2025, and x equals 8, that means 8 cube upon 2025, which is 512 upon 2025. And if I do this, then the answer that I get is minus 512 upon 2025, that is 0.3872. So you can clearly see that between 8 and 7, the 50th percentile lies. So 50th percentile lies here, which means the median is certainly 8. So your mode is 9. The median we just found out, that is 8. And this simply means that m minus small m, which is this right here. So mod of m minus small m, which is mod of 9 minus 8, that is obviously 1. And do we have an option of 1? Yes, option B. So here we'll say that answer is option B. So this is how you approach the difficult sums. That is, yes, you need to think a little, but the problem is what students may do is they may try to solve mode and median purely using formulas. And that formula based approach, like, you just remember the formula and you apply that. It kind of works in your 11th, 12th exams mostly. But in an exam like ACET or in professional exams that you may give in future for actuarial, you have to be very clear with the first principles and the foundational knowledge. And once you know that, then you see how easily we were able to find the mode and how logically we went about the median. Imagine 8 is the median, but you start from 0. So you've calculated the probability CDF for 0, then 1, then 2, and so on till 8. You'll get the answer, but it will be just much more longer. Correct? So the answer is 1 for this question number 1. And with that, we now move to the next question, question 2. So this question says, suppose x is a random variable with the probability density function given 1 upon lambda square x into e raised to minus x upon lambda. Okay. If 2 is the unique mode of the distribution, then lambda equals what? So now again you are given mode, but in this case there is no intuition you can apply to the mode. You have to use the formula. So your fx is 1 upon lambda square x into e raised to minus lambda x, correct? Or rather e raised to minus x upon lambda. And we have to find the mode. Again, let's observe what is mode. So if this is x and this is f of x, that is a PDF. Let's say you have a curve like this, simple curve like this. Then can I say mode is simply the maximum value. So this will be the mode, that is the maximum value of this function. So since the probability density function is the function of the probabilities, I want to find at which point of x do I get this maximum value. Can I see? All I'm trying to find is the maxima of f of x. And that is obviously a formula to find mode, that is for a continuous distribution. For finding the mode, all you need to do is you need to find the maxima, that is the point which is the maximum value of the particular function. So if you remember your 12th standard mathematics, how do we find maxima? So to find maxima, what you do is you differentiate, you find the differentiation d of fx by dx. So the idea is, differentiation, like in general, if I talk about intuition, differentiation for an increasing function, this will be a positive value. For a decreasing function, it is a negative value. But for two cases, this differentiation is 0. So for two cases, your differentiation or f dash x is 0. And what are those two cases? Either it is the maximum value of the function or it is the minimum value of the function. That is, it's either the maxima or the minima. So in this case, I want to find the maximum value. I hope you remember, once we find f dash x equals 0, to check whether this is the maxima or minima, what you do is you calculate you find the second differentiation. So the second order of differentiation, if that is less than 0, then it is a maxima, and if that second order is greater than 0, then it is a minima. But the concept is, I need to find the first differentiation, and as you can see, because it's a maximum value, what we are seeing is that, okay, in that small short span of function, there is no change, which is it has peaked and then it will start falling. So that turn will happen from increasing to a decreasing function. So we want to find maxima of the function and equate that to 0. Our function is 1 upon lambda square x e raised to minus x by lambda. So let's try to differentiate that. 1 upon lambda square x e raised to minus x upon lambda by dx. Can I say constant 1 by lambda square goes outside? Like it will stay constant only because it is getting multiplied with the remaining function. And what we are finding is d e raised to minus x by lambda into x upon dx. We have to apply the uv rule here because we have two functions, e raised to minus this and x. So we'll apply the uv rule, and just so you know, the uv rule is something like this. duv by dx is simply u dv plus v du, obviously both by dx. So that's the uv rule of differentiation, which is what we'll be applying here. So differentiating x into e raised to minus x by lambda by dx is simply u, that is x, into differentiation of v, differentiation of e raised to minus x by lambda upon dx plus v, that is e raised to minus x by lambda into dx by dx. This is obviously 1. So what you are left with here is x into differentiation of this. So differentiation of e raised to anything is the same, e raised to that particular thing, x upon lambda. But then you will apply the chain rule, and therefore you'll say now we want to find differentiation of minus x by lambda by dx. And this will simply be plus e raised to minus x upon lambda. If I just apply this differentiation, we have x e raised to minus x upon lambda into the differentiation of this. So minus 1 upon lambda is constant and dx by dx is 1. So this is simply minus 1 upon lambda plus e raised to minus x upon lambda, and this should be equal to 0, correct? So therefore what we say is x or negative x into e raised to minus x by lambda, the whole upon lambda, plus e raised to minus x by lambda should be equal to 0, which means therefore e raised to minus x by lambda should be equal to x upon lambda into e raised to minus x by lambda. E raised to minus x by lambda gets cancelled on both the sides. So therefore what you're left is 1 is equals to x by lambda. Therefore x is equals to lambda. So what we find by this differentiation is that the mode should be x equals lambda. You should ideally check this, that whether x is equal to lambda is the maxima and not the minima, by looking at the second differentiation. I'm not doing it, but if you do go with the second order differentiation, you will realize it's a negative value. So I'll just write here that you can check that f double dash x is less than 0, and therefore x is equal to lambda is the maxima or the mode. But we are given that x is equal to 2 is the mode, right? Because 2 is the unique mode of the distribution. They've already said it in the question. So therefore this means lambda is equals to 2. So the value of lambda, which is what the question was, will simply be a, that is 2. And here you can write that the answer is simply A. So hopefully this was clear. We had a function, we were given the mode. All you need to do is find the mode yourself, and based on that you will get this equation where you can then find out what is the final value of the answer. Correct? And you may have noticed that, I had this 1 by lambda square constant outside, which I then completely ignored. The reason I ignored it because it was multiplying and we are getting the final answer is 0. So that's why we just put that constant on the other side and it will be 0 only. That's why we removed the constant. Correct? So hopefully everyone is clear with this second solution, and if all okay, we'll now move to the third question. So very good, interesting normal distribution question again. That is, the time taken by employees to complete a routine task in a company is normally distributed with a mean of 50 minutes. So how long does it take you to complete the task? It's a normal distribution with mean of 50, standard deviation of 10 minutes. Okay, sigma is 10 minutes. What is the probability that a randomly selected employee completes the task in between 40 and 65 minutes? Okay. Use the following values from the standard normal distribution. So because you may not have the table, they've given you two values which should help you to find out this probability. Okay. So let's try and find this. X follows the normal distribution with mean as 50 and variance as 10 square. 10 is the standard deviation, so 10 square is the variance. Okay. Now X follows normal with 50 and 10 square. You have to find the probability that a randomly selected employee completes it between 40 and 65 minutes. So essentially you have to find the probability that X lies between 40 and 65. So how do you find this probability? So essentially you have, let's say, a standard normal distribution or a normal distribution. So something like this, a bell curve. This is obviously 50. And you have to find probability that it lies between 40 and 65. So something like this. Let's say this is 40 and let's say this is 65. You have to find the area under this curve. So the shaded region essentially. This is what we need to find. So if you think about it, can I say this is simply probability that X is less than 65, which would be, just to show you in the diagram, that will simply be 65, and we are finding probability X less than 65. So we are finding this entire region essentially minus probability that X is less than 40. So I'm saying this probability X less than 65, and from this I will subtract probability X less than 40. So when I do this, essentially I'm subtracting this region, that is 40, and I'm subtracting this region, correct? So what I'm left with is the area between 40 and 65, which is exactly what I wanted, correct? So this is an intuitive way for you to understand, why these formulas exist. You can understand otherwise also that, okay, because we want to lie between 40 and 65, I'm saying x less than 65 minus x less than 40. That will give me the range of 40 to 65. But these diagrams also help a lot to intuitively visualize what we're exactly doing. Okay. Now, can we find this? Yes, it's a normal distribution. So we can just directly apply. That is, this is nothing but probability that z is less than 65 minus 50 upon 10. So what did we do? So we apply the standard normal distribution, that is probability z less than whatever is given x minus mu upon sigma. So that's exactly what we are doing here. Minus mu, that's 50 upon sigma, that is 10, minus probability x less than 40 minus 50 upon 10. And this simply becomes probability z less than 15 by 10, that's 1.5, minus probability x less than, this is minus 10 upon 10, that is minus 1. So this is obviously phi of 1.5 minus probability x less than minus 1 is, so we have x less than minus 1. In the question we are given phi of 1. So what we are given is x less than 1. What we need is x less than minus 1. And because it's a symmetrical distribution, probability that x less than minus 1 is the same as probability x greater than 1. Correct? Because it's symmetrical, so less than minus 1 is the same as greater than 1, this region. And how can we find greater than 1? So this x greater than 1 is then nothing but 1 minus phi of 1. Correct? Because probability x greater than 1 is 1 minus probability x less than 1, which is 1 minus phi 1. So based on the values given for phi 1.5 and phi 1, this becomes, I'll just write here in a better way, 1.5 minus probability x greater than 1. This is phi of 1.5 minus 1 minus probability x less than 1, which is phi of 1.5 minus 1 minus phi of 1. And we have those two values. So this is 0.9332 minus 1 minus 0.8413. And if you solve this, you should get your answer as 0.7745. So you can solve this, you'll get that, okay, the area under the shaded region is actually 7745, which obviously intuitively means that there is a 77.45% chance that an employee which I select randomly will be able to finish the task between 40 and 65 minutes. That's how you intuitively understand normal distribution. Correct? So the answer here is obviously B. So I'll just say that answer is simply B, which is applying the logic of normal distribution and using what is given in the question. Correct? So this is a good question. And with this, we obviously go to the final question for the day. That is the question 4 of your difficult category of questions. So very good question. I believe it is from the latest ACET exam. And again, if you are aware of the distributions, the knowledge of distributions, then it's certainly doable. Without it, it becomes very difficult to do it in the exam time. Okay. So let's read the question carefully and try to achieve this. So we are being told a gamer is testing a new online game where there are two types of treasure chests that appear at random. Okay. Rare and common. So there are two treasure chests. One is rare, other is common. Game developers claim that 1/4 of the treasure chests are rare while remaining 3/4 are common. So there are, let's say, if there are 40 treasure chests, 10 will be rare, 30 will be common. The gamer decides to test this claim by opening chests one by one and tracking their types. So he's trying to test. See, the developer wants to have 1/4 rare and 3/4 common. But what if the players find a way to, just find the rare chests quickly? Correct? That kind of thing happens. So you want to test this, and this kind of testing does happen. So you want to test this by he's just opening the chests one by one, and he will keep a record of it, right? That okay, how often did I find the rare ones? If let's say in my first 10 chests that I open, 5 of them were rare, then it doesn't make sense. The 1/4, 3/4 claim does not make sense, right? So that type of testing is doing. He assumes that each chest has a 1/4 chance of being rare and 3/4 of being common. This is exactly what was told earlier. He can clearly distinguish between the two types. Rare chest, common chest. Pretty sure the reward size will be different. So he can clearly assume that and see that. If the assumption is correct, that is, if this assumption of 1/4 rare and 3/4 common is correct, what is the probability that the gamer will open at least 2 rare chests before he opens 3 common chests? Okay, so that's where now the interesting part comes into place. That is, you have to open at least 2 rare chests before you open 3 common chests. And this is a type of thing where knowledge of distributions come in very handy. Because if you try to do this using first principles, you will be able to do it, but you'll need at least 10 to 15 minutes to be able to do that. And obviously within a span of the exam, that's not the case. The other thing is you can try and see if there is any distribution that fits here. Okay. So a good way to think about what distribution could fit is, you see that, okay, 1/4 chance of being rare, 3/4 chance of being common. It is kind of a yes, no type situation, that it's either A or B. There are only 2 options. And whenever you are doing trials where there are only 2 options, the distribution, the underlying distribution is part of the binomial family of distribution, right? I'm not saying the binomial distribution, but certainly the binomial family of distributions. Because in binomial, you have that success failure type of thing, right? So distribution is certainly a binomial family of distribution. We can decide on which is success and which is failure later on, but that's something to consider. Okay. Now, what are we told that, or what are we supposed to find? We are supposed to find probability that I will open at least 2 rare chests before I open 3 common chests. So firstly, can I find this type of probability using basic binomial distribution? The answer is kind of no, because it will be very difficult for you to write all the cases in that case. You can do it. Again, it will be a longer way to do it, but there is a much more specific distribution specifically for this purpose, which you might have read. That is, here we want at least 2 rare chests before 3 common chests. So 2 rare chests before we open 3 common chests. So here now we get a very good hint of what should be our success and what should be our failure. And before that, here we get a very good idea of what distribution we need to apply, and that, my friends, is simply the negative binomial distribution. Correct? Because we are given number of successes, number of failures, that type of thing. So we'll apply the negative binomial distribution, and more specifically we will apply the type 2 distribution. Why type 2? So whenever you're thinking about negative binomial distribution, just think, what is my random variable? If the random variable is number of trials, that is total number of trials or total number of experiments, in this example that would be total number of chests that you have opened. If that is the random variable, then you go with type 1 negative binomial distribution. And if your random variable is number of failures, so not number of trials, number of failures. See, number of successes plus number of failures is number of trials. So you can find both with either type. But just so that you apply the correct distribution in the first go itself, it will give you a very quick answer. So for that reason, you can identify what is your random variable. That is, if your random variable is number of failures, then you will apply the type 2 distribution. In this case, you can see common chest, finding a common chest is my success. Correct? Because we have a fixed number, 3 is the common chest, so our K is kind of 3. And at least 2 rare chests, which means our random variable is actually this rare chest. So rare chest is my failure, and this is also my random variable. This is where I need to find the probability. So this kind of gives me the fact that, okay, this means we are going with a type 2 distribution. Correct? So hopefully this logic is clear, that rare chest is the failure and that is my random variable. Accordingly, I will apply the type 2 distribution. Now, can we go ahead and find the probabilities? The answer is yes. So our distribution, that is x is obviously number of rare chests before 3 common chests. So number of failures before K successes, correct? So that is x. X follows the negative binomial distribution with K as 3, probability of success as 0.75. So that's our distribution. We have to find that probability of finding at least 2 rare chests before 3 common ones. So in a way, we have to find probability that x is at least 2. Can I say this is nothing but 1 minus probability x less than 2, which is simply 1 minus probability x could be 0 and minus probability x could be 1. So these are the two possibilities which we don't want. We want at least 2 rare chests. So 1 minus probability x is equal to 0, probability x is equal to 1. Okay. So for the negative binomial distribution, what is the probability distribution function? So this is something you need to remember, because the NBD distribution is kind of a unique one. That is, it is gamma of k plus x upon gamma of x plus 1 into gamma of k into p raised to k q raised to x. So this p raised to k q raised to x is still straightforward, because p raised to k is probability of successes. We want 3 successes. So p raised to k, that is fine. Q raised to x is showing the probability of failures. Q raised to x, x number of failures. And then we have this constant which we need to multiply this with. This is nothing but that combination part. So kind of your NCX type thing. And in a simplified way, this is what it looks like. For those of you who are not aware, gamma of a number, let's say gamma of x, is actually x minus 1 factorial. That's what it is. So the gamma may look intimidating. It's nothing but x minus 1 factorial. So for example, gamma of 4 is 3 factorial. That's it. Correct? So now let's try and find out x is equal to 0, x is equal to 1 probabilities. So how do we do this? So probability that x is equal to 0 is simply gamma of 3 plus 0 upon gamma of 0 plus 1 into gamma of 3 into p cube into q raised to 0. Now, if you simplify this left hand side, this is simply gamma of 3 upon gamma of 1 into gamma of 3. Gamma of 3 gets cancelled. What is gamma of 1? Gamma of 1 is 0 factorial, and 0 factorial, I hope you know, is 1. So this left hand side constant completely simplifies to 1, and then what you have here is 0.75 cube into 0.25 raised to 0. So the answer here is simply 0.75 cube. We don't need to simplify it now, we can do this later. But probability that you will not find a single rare chest before you find 3 common chests is 0.75 cube. That is just directly finding 3 chests which are all common. So 3 by 4 cube. So it's quite intuitive as well. Okay, what about probability that you will find 1 rare chest? X equals to 1. So this is gamma of 3 plus 1 upon gamma of 1 plus 1 into gamma of 3 into p cube into q raised to 1. This is equals to gamma of 4 upon gamma of 2 into gamma of 3 into p cube into q. We can simplify this gamma part. So that is 3 factorial upon gamma of 2 is 1 factorial into gamma of 3, that is 2 factorial. This into 0.75 cube into 0.25. If you simplify this left side, that's 6 by 2, so it's 3 into 0.75 cube into 0.25. So we have probability x is equals to 1 as well now. So now, can we try and find probability x being at least 2? The answer is yes. This is 1 minus 0.75 cube minus 3 into 0.75 cube into 0.25. And if you solve this on your calculator, you should get the answer something like 0.2617. So do we have this option in our options? The answer is yes. Your option D is exactly 0.2617, which means your answer here is simply the D option. And that is exactly how you solve this question. That is, you first understand the question itself, read it. You need to read it maybe twice to understand exactly. Then you start thinking, brainstorming that, okay, can I apply a distribution? Because I'm supposed to find probability. I need a distribution ideally. What distribution to apply? In exam, you may think, oh my God, this is taking so much time to figure out. But it's important. Once you figure out, okay, this is the negative binomial, type 2 distribution. After this, the sum is not very lengthy. You just need to find this probability, 1 minus this, solve for this in your calculators, and you get your answer. But without figuring this out, just directly trying to solve it using first principles, in this case, may be wrong and may be problematic. The only reason I say that is because of lack of time. If you have time, go with it. You can try and find 10 different ways of finding this answer. But because of lack of time, you have to understand that here you have to apply the negative binomial distribution and get this answer. Okay. So people, with that, we are happily done for the day. This was your statistics masterclass. I hope you had a lot of fun in understanding this, and all the very, very best for your ACET preparations. I hope you ace it, and that maths stats should become your strongest suit in that case, and hope to see you soon. So thank you so much everyone. Have a very nice rest of the day and all the best.